Good afternoon. Am I audible? Just mention in the chat box. Is my voice audible or not? Let's start this session. Any disturbances there, we just mentioned in the chat box. I will start once again with the theory, brief theory explaining about the nodal analysis. So, nodal analysis, it is a form of analysis that is used to determine the unknown parameters, voltage across the elements, or current flowing through any element, as well as you can even determine the node voltages. Here we are going to use Kirchhoff's current law and Ohm's law to simplify the circuit using nodal analysis and to determine the unknown parameters. So here uh, the, the nodes that we are going to identify, initially we will identify the nodes, how many nodes are there, we are going to count it. Among those nodes, one node we will consider it as reference node, which is also known as ground node, and the voltage at the ground node will be always, or the reference node will be always assumed to be 0. So the procedure to be followed is same thing which I have already told you, that here initially we will check how many nodes are there, means how many junctions are there. Okay, and after and we will assign numbering to each and every node. Okay, and one of the nodes we will consider it as reference node, and we will write 0 volts at the reference node. Okay, after that at each node we will apply Kirchhoff's current law and determine the node voltages. After determining the node voltages, we can even determine the branch currents. And if voltage drop across each element is asked in the question, we can determine the voltage drop across uh, voltage drop across each element. Okay, so let us see how to simplify the circuit using nodal analysis. So can anyone mention in the chat box, is there any disturbance? Is there any disturbance? Can anyone mention in the chat box? Is my voice clear? I think it is clear because just now I checked it in some other connective device that I have. So, okay. So in this numerical problem, we have to find the current flowing through 20 ohms resistor, and we have to implement nodal analysis here to determine the current flowing through 20 ohms resistor. So this is our 20 ohms resistor. We have to determine current flowing through this 20 ohms resistor by implementing nodal analysis. Let us see how to determine the current flowing through this 20 ohms resistor by implementing nodal analysis. So first of all, check how many nodes are there here. Okay, so let us see how many nodes are there. So these are the sources, one voltage source and one current source is there. From the current source, current will flow like this. From this voltage source, current will flow like this. And at this node, current will divide. So this is a node. Okay, at this junction, current is dividing. So this is a node. And current will flow like this. And whatever current that is coming from this source, both currents may meet here and they may enter in this resistor. So this is also a node. Okay, so current flows to 20 ohms, current flows to 10 ohms. Okay, and whatever current that is flowing through this 20 ohms, and that will return back to this 4 amperes. Some of the current may divide here, and it may add up with the current that is coming to the 10 ohms, and it may return back to this voltage source. So this is a node, this is a node. So total, actually what I can say is there are 4 nodes, 1, 2, 3 and 4. Total 4 nodes are there, But if you observe here, but if you observe in between this node and this node, there is no element. Simply a conductor is connecting these two nodes. Okay. So we already know that for the current to flow, there should be potential difference between two terminals. Okay. So since what to say, there is no element between these two nodes, therefore we can consider these two nodes as one node. Okay, these two nodes can be considered as one node. Okay, so here node 1, node 2, node 3 and node 4 are there, but in between node 3 and node 4 no element is there. Therefore you can join these two nodes together, and in between you can put a node and consider it as third node. Okay, so total how many nodes now? So if no element is there between two nodes, then you can consider those two nodes as one node. Okay, I hope you are able to follow. So see here what I have written: node 1, node 2 and node 3. So total we can say there are 3 nodes. You can draw it. Total 3 nodes are there. Okay, total 3 nodes are there. Okay, and if you observe, current is coming from the sources and it is entering these junctions or nodes. Okay, and current is leaving these nodes, and returning current is, the current is returning at these nodes, the lower nodes. Okay, so usually the nodes from where current returns, you can consider that node as reference node. Okay, this node you can consider it as third node, you can consider it as reference node or ground node. So you can put a ground symbol here and assume voltage 0 V. Sorry, voltage at this node is 0. Okay, voltage at this node is 0. So voltage at node 3 is 0 volts. Okay, so we can assume node voltages. Okay, you can write node voltage at node 1 voltage is V1, at node 2 voltage is V2, at node 3 voltage is V3. And V3 value, what is V3 value? It is 0 volts. V3 is 0. Okay, so I hope you people are drawing. So here, this is it. You mention V1, V2, and you can write V3. I didn't write here. You write V3. V has gone somewhere. Equal to 0 volts. Write V3 equal to 0 volts. Okay. Write V3 equal to 0 volts. If you can, you just draw it and write it down. Okay, I hope you have written. So now we have assumed node 3 voltage V3 equal to 0 volts. Now let us at each node, remaining leftover nodes are two nodes, V1 and V2, methods are V1 node voltage V1 and node 2 voltage V2. So node 1 and node 2 voltages are there. Okay, so node 1, node 2. So at these two nodes, let us assume some directions. So these directions represent the direction in which current is flowing. So these directions are our wish. We can assume in either any direction that we want. Okay, so we can assume any direction of the flow of current from these nodes. So for simplicity, for my own convenience, what I have assumed is at node 1, if you observe, I will take the laser. At node 1, I have assumed all how many branches are there? Branches that are meeting at node 1, 1, 2, and 3. 3 branches are meeting at node 1. So since 3 branches are meeting at node 1, okay, so I have to consider three current directions. Okay, similarly at node 2, 3 branches are meeting at node 2. Here also I have to assume 3 current directions. So for my own convenience, I have assumed all currents are leaving the node 1. Similarly at node 2, I have assumed all currents are leaving the node. Okay, they are moving away from the node through each branch. 3 branches are there at node 2, 3 branches are there at node 1, and I have assumed all the currents, okay, in these branches, these 3 branches, they are leaving the node. So this branch, this arrow mark is leaving this node, moving away from the node. This arrow mark, it is moving away from the node. This arrow mark is also moving away from the node. That means all these the branch currents that I have assumed here, they are leaving the node. Here also at node 2, all the currents are leaving the node. You can assume all currents entering the node. Okay, you can reverse these arrow marks. At node 2 also you can assume all currents entering the node, or your wish. If you want, you can assume any of these currents entering and any of these currents leaving. Okay, it's your wish. These arrow marks which I have assumed, they represent the current flow of current flowing through each branch. Okay, direction of current flowing through each branch. You just see the direction that I have assumed here. One of the directions, it is entirely not possible. See, in this branch where 10 ohms resistor is there, I have assumed both opposite current directions. Current can flow only in one direction in one branch. In the same branch, current cannot flow in two directions. Okay, so these directions which I have assumed, they are just temporary. Okay, see, even you also observe in this branch in which 5 ohms resistor is there, the current direction that I have assumed here is current flows from node 1 towards the source. Current can always flow from source to load, not load to source, isn't it? So this assumed direction is exactly opposite to the actual current direction in this 5 ohms, but I have assumed in the reverse direction. Similarly here also, see, arrow mark is upward. So the current from the source will flow in this direction. Okay, in this direction. I will just draw it. I will try my current can flow in this direction. Actual current direction is this, but I have assumed in the opposite direction. Okay, so here these are just assumed directions. Okay, so whatever current direction that we are going to assume, okay, when you calculate the currents, if current value you get negative, that means that the assumed direction is opposite to the actual current flow direction in the given circuit. Okay, so actual current flow direction in this branch is this. Actual current flow direction in this branch is this, but I have assumed in the opposite direction. So assumptions are our wish. So since I have assumed in this opposite direction, definitely whatever current that I am going to, magnitude of the current that I am going to calculate, that value will be negative. Negative, for example, minus I1 I am going to get. I will get minus value. Here also some I2 or I3, whatever. So let us assume I2. So that current definitely it will be negative value. Okay, so whatever as current and current directions that you want to assume your wish, you can assume any directions. These directions you have to assume your own. It's your own wish. You can assume any directions, and if when you calculate the current values, if you get negative value, you can write a statement that my actual current direction is opposite to the assumed current direction. So the current value is so and so. Whatever value that you get, you can write it down later on. Okay. Now for my own convenience, what I have done is I have assumed all currents leaving node 1 and I have assumed all currents leaving node 2. Okay. Now let us write down. Let us apply Kirchhoff's current law at node 1 first of all and write down the nodal equations. Okay. For that, what I am going to do is I'm going to copy this image and copy and paste it in the next slide. Okay. So now if you observe here at node 1, okay, at node 1, I have assumed all currents are leaving. So all currents are leaving, so you can add all currents together. Okay. If one current is entering, another current is leaving, the algebraic sum of entering current should be equal to the algebraic sum of leaving currents. You can implement that statement of Kirchhoff's current law. Here all currents are leaving, so the algebraic sum of all leaving currents equal to 0. Or another statement, algebraic sum of all entering currents equal to 0. So here our currents are algebraic sum of all leaving currents. So here let us write down the nodal equation. So 3 branches are there. I will get 3 terms. Okay. So see here, current has started from this node, this arrow mark. You just observe this arrow mark. Current has started from this node. It will end at this source. So the potential difference. I have to determine the current in 5 ohms resistor now. So current in 5 ohms resistor is potential difference across this element. On this side of this element is 20 volts. On the other side it is V1. Okay, on one side the voltage. This is 5 ohms resistor. This side 20 volts is there. This side V1 is there. So potential difference divided by resistor will give us current through 5 ohms resistor. So what is the potential difference? 20 minus V1 or V1 minus 20? It will depend on what direction that you have assumed. You have assumed that current is starting from V1 and moving towards the source. So V1 minus 20 you have to write. Why we have written, instead of writing 20 minus V1, we have written V1 minus 20. Why? Because we have assumed that current has started from node V1 and it is moving towards the source 20 volts. Therefore, V1 minus 20 divided by resistance value, voltage by V by R. V by R is nothing but current. V by R is current. Write once again eraser. V by R is equal to current. We already know that. V by R equal to current or V1 difference V2. Okay, potential difference across the resistor. Okay, if this is a resistor, if this is V1, sorry. If this is V1, if this is V2, and if this is R. So what is I? What is I? I equal to what? V1 minus V2 or V2 minus V1 divided by R. Okay. So that is the current. So current flowing through first branch. In current flowing through 5 ohms resistor is V1 minus 20 by 5. Now what about current flowing through 10 ohms? V1 minus V3. What is V3 value? 0. So V1 minus 0, you can write V1 minus 0 divided by 10. I didn't write 0 here because even if we add or subtract 0, it is not going to make any difference. That's why I didn't write here. So V1 minus 0 by 10. Okay. Next. Next, current flowing through one more branch is there. This is the another branch that is connected to node 1. So current flowing through this 10 ohms is how much? V1 minus V2. V1 minus V2 divided by 10 will give us the current flowing through this branch. So 3 branches are there at node 1. Okay. So we have written 3 branch currents. These are the currents. So algebraic sum of all currents leaving the node equal to what? 0. According to what? According to Kirchhoff's current law. Okay. So applying Kirchhoff's current law at node 1. You can write that statement. Here I have written the nodal equation at node 1. Instead of writing that, you can write applying Kirchhoff's current law at node 1. So V1 minus 20 by 5 plus V1 minus 0 by 10 plus V1 minus V2 by 10 equal to 0. Okay. Now I will remove this image. Now just simplify this. Okay, you know mathematical simplification. So if you simplify, you will get 2v1 minus 40 plus v1 plus v1 minus v2 by 10. So here 2v1 plus v1 plus v1 means 4v1 minus 40 minus v2 equal to 0 you will get. I have written this equation in terms of v2. If you don't want, you no need to write. You can consider the above equation 4v1 minus v2 equal to 40. You can write like that also, your wish. Okay, simply if you have a scientific calculator, you can simplify it and okay, you can easily simplify it. There is no need for you to work hard. Okay, so if you have a scientific calculator, that is more than sufficient for you. So write down equation 1. Okay, so that is V2 equal to 4V1 minus 40. If you have any doubts, you can type in the chat box so that I will clarify your doubts. If you have any doubt till now, you just mention in the chat box. If you have doubt, you just mention in the chat box. Shall I proceed? If you have any doubts, you can type in the chat box. Now, nodal equation at node 2. For that, once again, I am going to copy this image. So, applying Kirchhoff's current law at node 2. This is our node 2, isn't it? This is our node 2. Okay, so how many branches? 3 branches are there, so you will get 3 branch currents. Okay, so you will get 3 branch currents. So if you see here, in this branch, the current is traveling from V2 to this source. What type of source is here? Current source. So this branch current is nothing but source current. That's it. But our assumed direction is opposite to the actual flow of current here. Current flow direction. It is opposite. So minus 4. Okay. The current in this branch is how much? Minus 4. Why? Because I have assumed the opposite direction of current flow. Therefore, minus 4. Next another branch. This branch, 20 ohms branch. So what is the current flowing through 20 ohms branch? V2 minus what? V2 minus 0 volts. V2 minus 0. I'll write that there. V2 minus 0 divided by 20. Okay, V2 minus 0 divided by 20 plus one more branch is left over. What is that branch that is connected to node 2? This branch. So What is the resistance? 10 ohms. And the voltages across this branch is what? V2 and V1. So V2 minus V1 by 10. Okay, because current is flowing from V2 to V1, isn't it? According to my assumed current direction, current is flowing from V2 to V1. So V2 minus V1 by 10 equal to 0. So minus 4 plus V2 by 20, V2 minus 0. Okay, V2 minus 0 means V2, V2 by 20 plus V2 minus V1 by 10 equal to 0. So I will just remove this image from here. Okay, I have removed the image. Now just simplify this equation. You will get minus 80 plus V2 plus 2V2 minus 2V2 by 20 equal to 0. Here 2V2, V2 terms are 3, V2 terms are there. 3 V2 terms. Where is V1? Oh, I have something is wrong here. So what is this? This is V1. It has converted into image. Okay, I will, 1 second, I will modify this. Okay, V2, 2V2. This is 2V1, not V2. I'll just edit it and I will just paste it. 1 second. Okay, so unfortunately by mistake I wrote V2 here, so it was V1. So minus 80 plus V2 plus 2V2 minus 2V1 by 20 equal to 0. So just simplify this, this will become 3V2 and okay, 3V2 20, you send it to the right side, it will become 0. So 3V2 minus 2V1 equal to 80. So consider it as equation number 2. Okay, now we have two equations. You can simply simplify these two equations using the scientific calculator. Okay, if you complete, if you are writing it down in your notes, and if you complete, you just mention C in the chat box so that I'll come to know that I have to change the slide. Okay, I don't know how many of you have, very few members have joined, but even the joined students are listening to the session or not, I'm unable to understand. So if you respond in the chat box, I will come to know that you people are following the class. Okay. So completed. Now we have two equations. Just simplify those two equations. Okay, substitute equation 1 into your wish. You can do in either way. You just take a scientific calculator and substitute both equations. You will get V1 and V2 values. Here I have done manually. So I have substituted equation 1 and equation 2. So I have got 3 into 4V1 minus 40 minus 2V1 equal to 80. So all the terms are in terms of V1. So I have calculated V1 here. Okay. So we just expand this 12V1 minus 120 minus 2V1 equal to 80, 10V1 equal to 200 and V1 equal to 20 volts you will get. Now I have got V1, I can determine V2. So you can either substitute V1 in equation 1 or equation 2, your wish. So you just substitute it. I have substituted in equation 1 and I have got V2 value. So node voltage V1 is 20 volts. Node voltage V2 is 40 volts. Node voltage V1 is 20 volts. Node voltage V2 is 40 volts. So if you remember, they have asked us to determine the current flowing through 20 ohms. Okay, they have asked us to determine the current flowing through 20 ohms. So simply, what is the equation for the current equation to determine the current flowing through 20 ohms? So this is 20 ohms, isn't it? This is 20 ohms. What is the current through 20 ohms? V2 minus 0, V2 minus 0 divided by 20. Okay. So this is the current through 20 ohms. What is V2 value? V2 is 40 volts. So 40 divided by 20. Okay. So 40 divided by 20. So you will get 2 amperes. Current flowing through 20 ohms. So you can determine current flowing through any element. You have node voltages. You can determine current flowing through any element here. So if you complete, we will go to the next numerical problem. If you complete, mention in the chat box so that I can proceed to the next numerical problem. Okay. So this is a dependent source numerical problem. You can see. We have to find the current through R3. Where is R3? R3 is here. Okay. This is R3. We have to determine the current flowing through R3. So they have even mentioned, they have given some notation for the current Ix. Okay. Current flowing through R3 is Ix. And if you observe here the dependent source, it is a dependent current source. And the current through dependent source is 2Ix. So current flowing through R3, if you are able to determine the current flowing through R3, you can determine the value magnitude of this dependent current source. Okay. So just copy it down, note down the circuit, draw the circuit as quickly as possible. So if you observe there in this circuit, there is no need for us to assume the node voltages. In the question itself, they have mentioned the node voltages. Okay, V1, V2, V3, of course. One more node is there, V4. One more node is there, V4. They didn't mention that V4. What is the value of V4? It is 0 volts. I'm unable to write V4. So V4, its value is equal to 0 volts. This is V4. So node 1, node 2, node 3, and node 4. Total 4 nodes are there in this given circuit. Okay, so node 1 voltage is V1, node 2 voltage V2, node 3 voltage is V3, and node 4 voltage is V4. And I am assuming node 4 as the reference node. Okay, I am assuming node 4 as the reference node. So if node 4 is the reference node, then its magnitude is assumed to be 0. Yes, reference node voltage is always 0. If you complete drawing the circuit, just mention in the chat box, because it takes some time to draw the circuit. So today's session is very important because mesh and nodal analysis is the basics for all the other concepts. Okay, to simplify any circuit, we have to implement Kirchhoff's current law and voltage law. We have to use mesh or nodal analysis. So today's session, morning session and afternoon session, both are very, very important to simplify any circuit, to determine currents or voltages in any circuit. This is the basics. So I don't know why only very few members have joined this session. Okay, even morning session, few members were there. Now still very few members, but I don't have any other option. I want to save my time. That's why I'm taking this session. So okay. Now I will just copy that image in this slide. Now apply Kirchhoff's current law at node 1. So where is node 1? This is node 1. I didn't write node 1, 2, 3. If it will better if it will write at node 1. Okay, apply Kirchhoff's current law. So here I didn't mention any directions here. Okay, you can assume directions. I have assumed, I will tell you what I have assumed here is simply all currents, I can assume all currents entering and all currents leaving, but without this current I have considered positive, this current also I have considered positive. Okay, so this current I have assumed it as V1 minus V2. Okay, so I have assumed current is leaving this node. Okay, so simply I have added. It doesn't matter actually, your wish. You can write anything, any direction, as I have already told you. You can assume all currents are entering or all currents are leaving. If you assume current direction is opposite, you will get negative value. That's it. Magnitude will not change. So here simply I have assumed two currents entering and one current leaving, and I have added all the currents at this node. So this is IS, source current IS, okay, plus another dependent source current is entering this node V1, so 2IX, okay, plus V1 minus V2 by R1, okay, V1 minus V2 by R1 equal to 0. Okay, so you can even write here entering currents equal to leaving currents, or what I can assume here is it's better if I assume all current are entering, I should write, so this I can modify this V2 minus V1 by R1 is okay, yeah, okay, I can write like this. Okay, if all currents are entering, because not all currents entering, yeah, all currents are entering means current has current will start from V2 and it will end at this node V1 while flowing through R1. So I must write V2 minus V1 if I assume current flowing through R1 in the opposite direction to the equation that I have written. Okay, so according to this equation, V1 minus V2 means current is leaving V1 and entering V2. Okay, this equation, this one equation, you can consider it as equation 1. Now apply Kirchhoff's current law at node 2. This is node 2. Okay. So here I have assumed current is leaving. Here again I have assumed current is leaving. Here again I have assumed current is leaving. Node 3. Okay, all currents are leaving. So V2 minus V1 by R1. Okay, V2 minus V1 by R1. Next, this current through R2 is V2 minus 0 volts. And no need to mention, here you can assume V4, node 4, V4 equal to 0 volts. So V2 minus 0 or V2 minus V4 by R2. Okay, next, third branch, V2 minus V3 by R3. Okay, I will take the laser. Once again, I will tell you the equations. So here I have assumed all currents are leaving. I didn't mention any leaving currents here. If you want, you can draw the leaving currents. V2 minus V1 by R1 plus V2 minus 0 by R2 plus V2 minus V3 by R3. Okay, 3 branches. Here earlier at node 1 also 3 branches. At node 2 also there are 3 branches. Next at node 3 there are 3 branches meeting at this node 3. Okay. So I hope you are able to follow. At node 3, let us see. I hope you have written these equations. No need to draw this circuit. You can simply mention the arrow marks. That's it. At node 3. So let us apply Kirchhoff's current law at node 3. I'm just giving some time to people so that you can copy it down. Now at node 3. So let us go to node 3. I will just copy this image in the next slide because node 3 equation. Okay. So here at node 3, this is our node 3. So here V3 minus V2, V3 minus, yeah. So I have assumed all the currents are leaving this node again. I have assumed current is leaving, current is leaving, current is leaving. So I have assumed all currents are leaving this node. So V3 minus V2 by R3 is one current equation. V3 minus V2 by R3. Next V3 minus 0 volts. V3 minus V4 by R4. Okay, that is next equation. V3 minus 0 by R4. Next one is what? In this branch, only current source is there. Whatever current source magnitude is there, you just write it down. 2Ix. Okay. Now, they have asked us to determine the Ix value. So, what is Ix? Ix is nothing but V3 minus V2 by R3. So here they didn't give any values. R1, R2, R3, R4 values. We don't know R1, R2, R3, R4 values. As well as we don't know the source voltage, source current magnitude. So only this is just a theoretical circuit. Okay, this is just a theoretical circuit, nothing else. Okay. So we have for at each and every node all currents, we have assumed all currents are leaving. Only for the node 1 I have assumed one current is leaving, all currents are entering. Okay. So I can even modify this equation at node 1. If you are not satisfied with this, actually I myself am not satisfied with the equation that I have written there. If you want, you can change it. 1 second. You can change it. Here, if you observe here, the source, this is one source, this is one, both the currents are entering. It's better if we assume R1 current is also entering. So if I assume R1 current is also entering, so what I can do is I can write here V2. This is more satisfactory, isn't it? Because I will just expand it and I will tell you. Earlier, I have assumed I always prefer either all currents are entering or all currents are leaving. Then only it is because we can simply add all the currents together. That's the only reason I prefer all currents are entering or all currents are leaving. So here I have assumed current Is is entering. current 2ix is entering this node, and I have assumed current flowing through R1 is also entering. So if current is flowing through R1 is entering, current has started from V2 and ended at V1. So V2 minus V1 by R1 plus Is plus plus 2ix is equal to 0. Now it is more satisfactory for me. For second equation, I have assumed all currents leaving. Okay, second equation means currents at node 2. All currents I have assumed leaving. Okay, so V2 minus V1 by R1, V2 minus 0 by R2, V2 minus V3 by R3. Yeah. So at node 1, I have assumed all currents entering. This is the equation for that. At node 2, I have assumed all currents leaving. At node 3, I have assumed all currents. Again, I have assumed all currents are leaving. Okay. So, leaving currents, what are the leaving currents? V3 minus V2 by R3, V3 minus 0 by R4, and the next current is 2Is. So, just add all these currents equal it to 0. And they have asked you to determine Ix current. Ix is nothing but what? Ix is the current flowing through R3. So Ix is the current flowing through R3. What is the current flowing through R3? I will better take laser. My cursor, it always irritates me. So this is Ix. So what is Ix? V3 minus V2 by R3. V3 minus V2 by R3. That's it. This is the answer. Why? Because we don't have any magnitude values, resistance values, or source current values here. Therefore, this is the answer. That's it. No further simplification is required. Okay, so let us go to the next numerical problem. I hope you have written. So I just repeated twice. Why? Because at the beginning at node 1, I have assumed one current opposite to the other two currents. Two currents entering and one current leaving. So it was not satisfactory for me. So that's why I have changed that equation. So if sufficient people are not there, it's better. I will just conclude this session. It seems many of you are not there. It seems only I could see very few members. If only few members are there, then what is the need to take the session if very few members are there? Concurrent viewers, I can see only 2 members. It seems others are sleeping. Let me check how many people are there online. No, it is showing concurrent viewers 0. Just to mention in the chat box how many of you are listening. See, it is showing 0. Concurrent viewers are 0. So one more numerical problem I wanted to discuss and conclude, but I could see no one is there in the session. So it's better I will just quit the session. Only 3 members. You can see on the display, it's not showing you on the display. You can see how many concurrent viewers are there. It is showing almost 0, isn't it? It seems I don't have any other work. Since I'm, what to say, I'm not busy, I'm taking this session. Don't I have any other work? Okay, one more limited problem and I will conclude this session. I don't want to proceed. It's wastage of my time, isn't it? If no one is interested to attend this session, for full sake, I should take this session. Hmm? Is it for my own sake? What am I going to gain by taking this session? Okay, next numerical problem. We have to find the voltage drop across R2. So where is R2? This is R2. This is R2. We have to determine the voltage. Voltage across R2, they have mentioned something V0. Okay, V0 is mentioned here. So V0 is the voltage across R2. Okay, and if you observe here, there are two independent sources, one voltage source, one current source, and one dependent source. And in this dependent source, if you see this, the dependent source, it is a dependent voltage source. Okay, and its magnitude is depending on voltage across R2. So magnitude of this source is depending on voltage across R2. Just draw the circuit. If you complete, mention C in the chat box so that I will proceed. I will conclude after this numerical problem. Means I will close the session. If no one is interested, why should I waste my time? If you complete, just mention in the chat box, type C, draw the circuit quickly. Okay, so let us proceed. So here, just look at the circuit. So here let us assume some node voltage here, source voltage, they have mentioned V1. So here how many nodes are there? This is one node, this is one node, this is one node, and this is one node. Since no element is there at the bottom, So we will assume those two nodes as single nodes. So total 3 nodes are there. Okay, total 3 nodes are there. Let us consider third node here. And just give a ground symbol. Assume voltage 0 volts. Here I am assuming node voltage V2 and here I am assuming node voltage V3. You can assume here node voltage V4. Okay, so the voltage at node where R2 is connected. Okay, let us assume it is mentioned V2. Okay, so since okay. So I have assumed here V2, but here above whatever I have written is in the opposite way. So I have considered the same. So okay. So since the voltage across this R2 is V0, let us assume that's what I have written at the top. I didn't read that. So let us assume you can even if you assume in the way that I have already told you, that I have told you to consider this as V2 and this as V3 and here you consider it as V4. Even if you assume like that, you can write down the equations based on the assumed nodes. Okay. So but since my content I have already typed all the equations and I have framed the content already in these slides. So I can't change. If I want to change and modify based on what I have taught you just now, then it will take some time. So let us assume whatever is written here. So let us consider node voltage at this node where R2 is connected as V0 and node voltage of the other node as V2. So I'm not changing what I have written here. Okay, why? Because then I have to change all the equations in the next slide. Okay, V3 equal to 0 volts. Okay, consider this as V0 and consider this as V2. So I didn't read what is there in this slide. Simply I was about to explain in my own way. Okay, so even if you write V2, you can equate it to V0 and here if you write V3, it doesn't matter actually. It's okay. So consider this as V0 and this as V2 and this as V3. This one, bottom one, V3. Okay. So now let me copy this in the next slide. Now see here, what did I say earlier in the previous slide? I told you, first of all, I told you this as V2. Later I told you to assume the voltage as V0. So consider this node voltage as V0. This node voltage as V2. Okay. Okay. Now let's determine this V2 value. We don't know V0. They have asked us to determine the voltage across R2. So we have to determine V0. So before that, let us see whether we can determine V2 value. So what is V2? V2 is equal to R4, isn't it? R4 into current I1. See, resistor and current source, they are connected in parallel here. Okay, so they are connected in parallel. So whatever current, that is 3 ohms, is 3 amperes, sorry, not ohms, 3 amperes is there, same current will flow through this. The source current will flow through this R4. Okay, source current I1. Okay, I1 value is 3 amperes, that will flow through this R4. R4 value is how much? 16. So V2 is equal to what? V2 is equal to 16 into 3. That is equal to complete. Okay. This is the voltage. I am unable to write V. This is the voltage, node voltage V2. Okay, this is the node voltage V2. Okay, so even if you have assumed that first I told you to assume it as V3, we might have converted this V2 to V3. Okay, notations are our wish. Okay, so there is no need to by heart the notations and all. So that's what the problem with me. I can't by heart. Whenever I try to solve a numerical problem, each time I solve it in a different pattern. Each time I won't consider every notation, same notation. I won't give the same notation. Okay, that's why at the beginning instead of V0, I told you to consider V2. Okay. So V0 and V2. So we have determined just now, we have determined V2. So I hope you have understood. I hope you have understood how to determine V2. So V2 is equal to what? 16 into 3. That's it. 16 into 3, you will get V2 value. Now, we know V2 value, that is how much V2 value is now, how much? 48. Now, let us apply KCL at node 1. Okay. At node 1. KCL at node 1. I didn't write here. Simply I have mentioned apply KCL at node 1. Okay. So let us apply KCL at node 1. So where is our node 1? This is our node 1. Well, what is the voltage that we have assumed? Voltage across the R2 is nothing but node 1 voltage. Now apply KCL at node 1. So now applying KCL at node 1, we have to assume current directions, isn't it? So let us assume all currents are leaving. All currents are leaving. Okay. So let us assume all currents are leaving. What is the voltage at this node? It is V2. Node 2 voltage. Okay. Now we let us consider branch R1. So what is the voltage? V0 minus V1. Okay. V0 minus V1 by R1. Next, what about R2? What is the current flowing through R2? V0 minus V3. What is V3 value? V3 equal to 0 volts. This is equal, not to. Okay. So V3 equal to 0. So V0 minus 0 by R2. Next, what about the current flowing through R3? This is R3. That is 4 ohms. So current flowing through R3 is V0 minus V2. Isn't it? V0 minus node voltage. V0 minus V2. Okay. V0 minus V2 by R3. But in between there is one more element is there, that is 2V0. Okay. So I will just erase all these. The current through this branch is in this direction. All currents are leaving. This is V0. This is V2. So V0 minus V2 divided by R3. That's what you should write. But one more element is there. 2V0. 2V0 is also there. So if you observe, positive terminal is this. So current should come out in this direction. Okay. But assumed direction is opposite. So minus 2V0. So you should also consider this voltage also. So V0 minus V2 minus 2V0 by R2 equal to 0. So I hope you are able to follow. Okay. So this is applying KCL at node 1. So I have assumed all currents leaving the node. I have assumed all currents leaving the node. So V naught minus V1 divided by R1, one expression. Next, V naught minus R2. V naught minus 0 divided by R2. Next, V naught, third branch. V naught minus V2 divided by R3. One more term is there. So V naught minus V2 minus 2 V naught by R3 equal to 0. Now just simplify this. And here we know V2 value, what is it? V2 is 48. So that I have written here. And we have how many unknown terms are there? V1, yeah, V1 value is known, that is 1 volt. And R1 is known, R2 is known, R3 is known. So only V0 is unknown term. All other terms are known terms. R1 is how much? R1 value is 1 ohm. I'll just expand this image so that it will be more visible to you. Is it visible? It's not at all. Okay. So see here, R1 is 1 ohm, R3 is 4 ohms, R2 is 2 ohms, R4 is 16 ohms, I1 is 3 amperes, V1 is 1 volt. Okay. So substitute all the terms. And determine V0. So voltage across R2. Voltage across R2 is V0. So after substituting and simplifying, you will get V0 equal to 10.4 volts. Just write it down if you complete in form. Completed? Okay. So these are the numerical problems. You people just refer to different textbooks and you can solve more and more problems by referring to different textbooks. So one more small topic is there, hardly 10 to 15 minutes topic. So I thought let me conclude that one also. Only 2 numerical problems are there. So I will discuss that also and I will conclude this session. Okay. So then this topic is principle of duality. Okay, within 10 to 15 minutes I will conclude this session. So principle of duality, it's a very small topic. So the electrical okay, so the electrical parameters, voltage, current, resistor, inductor, capacitor, electrical circuit parameters, you know, they all are they all have a dual relationship. Okay, they are formed by interchanging voltage and current in every expression. Okay, So they all have some identical behavior also. Okay. So the circuit which illustrates this identical behavior between voltage and current in two circuits or any circuits, that is known as principle of duality. Okay. So different elements have their own dual element. For example, if you see here in this image or in this slide, if you see here, if you consider element voltage, okay, voltage source, okay, so if you consider voltage, its dual element is current. Okay, if you consider voltage, its dual element is current. If you consider series circuit, its dual element of series circuit is parallel circuit. Okay, if you consider resistance, the dual element of resistance is conductance. If you consider capacitance, dual element of capacitance is inductance. If you consider reactance, dual element of reactance is susceptance. If you consider short circuit, dual element of short circuit is open circuit. If you consider KCL, dual element of KCL is KVL. Okay, so there is a dual relationship between different elements. Okay, so simply this dual can be formed, dual elements can be formed by interchanging voltage and currents in a given expression. Okay, they all have some identical behavior. Okay, so since they have identical behavior, see, voltage and current both have identical behavior. That's why voltage and current are dual to each other. Series and parallel, they also have identical behavior. That's why they are dual to each other. Resistance and conductance are also have they also have identical behavior. Therefore, uh, they are dual to each other. So I don't know whether you know that resistance is reciprocal to conductance. Okay, resistance is reciprocal to conductance. Similarly, capacitance and inductance are dual to each other, and so on. Okay, so just write down the dual elements. You just copy down this table. Based on this table, we will solve two numerical problems. They are just diagrammatical problems, means there will not be any equations here. Simply a circuit will be given. We will replace that circuit with its dual circuit. That's it. It's very simple concept. If you complete, just inform. Just draw this table in your notes. Based on this table, we are going to solve the numerical problems without any equation. Simply a circuit will be given. We will just modify that circuit. We will replace it with its dual circuit. Completed? Okay, so let us see. This is the circuit which has been given. So if you see here, simply they have asked us to find the dual network for the given network. That's it. Draw the circuit as quickly as possible. Even node is dual to mesh. Then mention in the table, it is not mentioned in the table, but node is dual to mesh. Mesh should be converted into node, and node should be converted into mesh. Just draw it as quickly as possible. It is in your hand. If you people quickly draw and You people quickly draw the circuit. We will conclude this session within 5 to 10 minutes. Did you complete? Okay then. So now see here in this circuit, there are three meshes. This is one mesh, this is another mesh, this is another mesh. So just now I told you orally that the meshes are dual to node. So in each mesh, consider a node. Consider node 1 in this mesh, node 2 in this mesh, node 3 in this mesh. Okay, so that's what I have done in the next diagram. You just see I have put a node here. So better I will put the node in this diagram. Okay, node. There is a person won't listen to me. Okay, I will try my best. Consider node 1, node 2, node 3. So node 1, 2 and node 3. Okay, consider 3 nodes. Now consider one more node outside this what is it, circuit. Consider it as node 4. Okay, consider it as node 4. Now from node 1, this is our node 1, isn't it? This is node 1, this is node 2. I'm just filling this circle. From node 1, okay, so node 4, whatever you have assumed here, this node 4 is nothing but our reference node. Okay, so from node 1 through this source, what is the source? Voltage source. Voltage source, what is the dual element of voltage source? Dual element of voltage source, what is it? Current source. Okay, dual element of voltage source is nothing but current source. So from this, draw a dotted line, not straight line. Draw a dotted line and draw a current source. I'm unable to draw because my cursor won't allow me to draw. Okay, and join it to the reference node. Okay, so this is V, so this should be I. Okay, so in between node 1 and node 2, what is there? C1 is there, capacitor is there. What is the dual of C1? Capacitor. Dual element of capacitor is what? Dual element of capacitor is inductor. Okay, just now in the previous table, capacitance dual is inductance. Okay, so in between 1 and 2, capacitor is there. So now draw an inductor between 1 and 2. Draw inductor between 1 and 2. Okay, this is C1, so write L1. Okay, here it is C1, write L1. I couldn't draw inductor properly. You people draw it. Okay, next. In between node 1 and node 3, what is there? Resistor R1 is there. Okay, so what is dual of resistance? Conductance. Dual of resistance is conductance. Even conductance symbol is also it looks like a conductance is also represented by a resistance symbol. So what you do is draw a resistor again. No need to convert this symbol. Okay, symbol is same. Conductance means G. So here R1 is there. So write G1. Here write G1. Similarly, in between 1, 2 and 3, this is 3, this is 2. What is there? L is there. So, what is the dual of inductance? Capacitor. So, draw a capacitor and draw a dotted line. I am drawing solid line with the cursor. I am unable to draw dotted line. So, what is it? L. Instead of L, write C. Okay. Okay. Now, here R2 is there. Where is my cursor? Yeah. Here R2 is there. Okay, R2. So R2 is connected to the reference node, isn't it? It is connected to the reference node. So R2 means R2 should be replaced by what? It should be replaced by a resistance. Should be replaced by a conductance. Whose value is what? G2. Okay, its value is G2. Okay. Now one more C2 is there. C2 is it is not between any two nodes, isn't it? It is not between 1 and 2, 2 or 3 and 1 and 3. Therefore, replace capacitor with what? With an inductor. I didn't draw inductor properly. With an inductor and connect it to the ground. Okay, C2 means you can, instead of the C2, you must write L2. So this is it. That's it. After drawing like this, you see here, I have drawn in this diagram. You see, in this mesh, consider node 1. In this mesh, consider node 2. In this mesh, consider node 3. Okay. So mesh is dual to node. Node is dual to mesh. Now, from node 1, draw a dotted line flowing through this source. So what is the source is? Source value is V. So replace it with a current source whose value is I, connected to the ground. Okay. Similarly, in between node 1 and node 2, what is there? Capacitor is there. C1. C1 is there. So draw a dotted line. Instead of capacitor, draw an inductor because inductor is dual to capacitor. Instead of C1, write L1. So in between 1 and 3, what is there? Resistor is there. That is R1 is there. Draw a one more resistor symbol. Replace R1 by G1. In between, okay, in between 3 and 2, what is there? Inductor is there. Replace inductor by a capacitor. There was L. Replace L by C. From 3, there is a capacitor here. Replace it with inductor. It was C2. Replace C2 with L2 and give it to the ground. And from 2, go through this resistor, that is R2, and give it to the ground. And replace resistor by another resistor symbol. Replace R2 by G2. Okay. This is how you must put the dotted lines and draw the diagram. You just, if you have not drawn properly, because I couldn't draw properly with my cursor, you can draw it quickly with the dotted lines. The dotted lines. Did you complete? It's a simple concept. It may look somewhat difficult. Simply you just look into the table that you have drawn. From that table, copy it down. That's it. From that table, write down the dual element. Completed? Okay. Now, redraw the diagram. Simply, there were 3 nodes, isn't it? Node 1, node 2. And you no need to draw like this. Okay, no need to even draw like this. as you wish. You just 1, 2, 3, as it is, whatever is visible here in the same format in some proper rectangular shape, draw it. So I have written 1, 3 and 2 in this pattern. I have written and I have drawn like this. No need to follow me. You can consider 1, 2, 3 nodes in a straight line, and after that, in between 1 and 3, what is there in between 1 and 3? G1 is there. If you might have written here 2, here I have written 3. If you might have written here 2, sorry, I have written 3 and again I wrote 3. Okay, if you write here 2, okay, that's what first thing comes in our mind, isn't it? After 1, we usually consider 2. After that, we usually consider 3. If you write 2 here, you might have drawn here what you might have drawn. You might have drawn inductor and you might have written L1. Okay, so if you write 2, you must, so based on previous diagram, you must redraw the diagram. Okay, just redraw it quickly. One more small 2 loop problem is there and I will conclude. Those who are unable to follow this duality concept, you can just mention in the chat box whether you are able to follow or not. Is it confusing? Completed. Okay, so one more numerical problem with only two loops are there. So here what is mentioned, find the dual network for the given network. That's it. So you just see here what are all the elements. 2 loops are there, means 2 meshes are there. So how many nodes will be there? 2 nodes will be there along with one more extra node outside the, isn't it? Here one node, did I take pen? Here one node will be there. Here another node will be there. One more extra node outside this, that is reference node. Okay. So node 1, node 2 and node 3. That is our reference node. Okay. So from node 1, go through this source. It is a voltage source. Replace it with what? Current source. Voltage source value is 5 volts. What is current source value now? Current source value will be 5 amperes. That's it. Nothing else. Okay, no need to calculate. Simply, if 5 volts is there, replace it with 5 amperes. That's it. Okay, what did I say? Did I say 5 volts? Current value should be 5 amperes, not volts. Sorry. I don't remember what it is. So here, there is a capacitor. Replace it capacitor with what? Inductor. Capacitor value is 1 farad. I am very, very talented. Capacitor value is 1 farad. So 1 Henry. Inductor value is 1 Henry. Similarly, in between node 1 and node 2, what is there? Current source is there. Replace current source with what? With a voltage source. See, arrow mark is downward. So, minus and plus symbol. Okay. So, this current source value is 1 ampere. So, voltage source value is 1 volt. Okay. Now, here one resistor is there in between 2 and 3. So, here I will draw one more resistor. Whose value is again 2 ohms. What is it? Conductance value, isn't it? So, conductance is reciprocal to resistance, isn't it? So, I should not write ohms. I might have written mho symbol. Reciprocal to resistance. So, I wrote ohm symbol. Write mho. Okay, write mho symbol. Similarly, here inductor is there. Replace inductor by a capacitor. Give it to node 3. And what is capacitance value? 1 Henry is there. So, write 1 farad. Okay. So here one more capacitor is there, replace it with an inductor. Okay, here 1 farad is there, write 1 Henry. Okay, so here once again one more inductor is there from node 1. Where is it, cursor? Yeah, node 1, the inductor is there, replace it with a capacitor. Inductance value is 2 Henry, so write 2 farad and connect it to the, you people draw dotted line connected to the ground. Okay, so this diagram is already available in my next slide. So see, this is how you must replace the elements with the dual elements. So this is the last one. So within 2 minutes I will conclude and I will give you the Google form to fill. You just complete this and redraw the actual circuit. Did you complete? Okay, now redraw the circuit. So this is the dual network of the circuit which has been given in the question. You can even mention one more node I didn't mention here. You can mention that. Where is the cursor? You can write this also here. If you complete, just inform. I will just upload the Google form. I have to create the Google form actually. I'll create the Google form and I will give it to you. I will send you the link. You can fill the link and you can realize. So you will just go through this concept later on when you are free. Because this duality concept, it may look complicated, but it is easy. If you complete, just write. Even one person types C. Okay, completed. Okay, I will Send you the Google form link. Fill the Google form. If you fill, after filling the Google form, just mention in the chat box and leave the session. I'm going to close the session after this. If you have filled, you can leave. Okay, since no one is there, I will just conclude this session. Responses are not changing. I'm concluding this session as I think whoever have attended, they have filled the Google form.